Hello and welcome to the video. This is part of the quad building for beginners series that's currently underway. I'll put links down below. This is the quad that we built during that series. It is a SpeedyBee frame with a SpeedyBee flight controller, and this one happens to have walk snail in it. However, last time I added a GPS and compass to the back end, and you can see all those videos using the links down below. That was all with Betaflight. However, in this video I'm going to go through and show you how to flash a quad like this onto INAV. Now, why would you want INAV over something like Betaflight? Well, if you have a GPS and compass attached, it gives you a number of distinct advantages over Betaflight for GPS flight modes. It not only does the GPS return to home, or what Betaflight calls GPS rescue, where when the mode or failsafe is activated, it will actually fly back to you, hover over the armed location, descend, hit the ground and disarm, all automatically. But INAV does a couple of extra things as well. It will also allow you to park the quad in 3D space, so you can just kind of set it to hover. You can take your hands off the sticks and it will just sit there, which is kind of cool. And the other thing you can do is you can also upload a set of waypoints and fly autonomous missions. So you can tell the quadcopter where it is and how you want to fly, hit the switch, and it will do that for you. The cool thing is that the INAV flight modes with the GPS stuff are a lot more sophisticated than Betaflight. So I will put INAV on certain quads, and all of my planes and wings that you ever see me building here on the channel always have INAV, because INAV also supports fixed wing as well. The big drawback is on a multi-rotor, you also need to have the compass wired up to the flight controller, or have an onboard compass that is protected from stray magnetic fields. And that's because INAV uses the compass along with the GPS to fly those more sophisticated modes like the mission planning and other pieces too. Because what happens with things like Betaflight figures out its direction, because it doesn't have and use a compass, by flying in a straight line and then figuring out where it was and where it is, kind of drawing a vector through those 2 points, and that is the direction it's travelling in. And it can figure that out from the GPS location. However, that doesn't work if the quad is also being blown sideways, and that's why you may have seen some of the GPS rescue flights, if you've ever seen that actually happen, why it flies in such a weird way. It's trying to constantly figure out the direction it's flying in. If, however, you have a compass that's connected and calibrated and working properly, you don't have to do any of that. You just follow the heading. So in this video, I'm going to go through all the separate steps, but might be a little bit longer than one of my normal ones. I don't want to split it up into lots of different things. I'll put time codes down below, but let's go on the bench and convert this Betaflight quad that we made in the series over to INAV 7. So the first thing I would recommend you do is to connect to the quadcopter and download the existing configuration. That can be done using a dump and diff all. But before you do that, I would also take a look at some of the tabs in Betaflight, specifically things like the ports. Make a note of how all the ports are configured. Have a look and make sure you know what the hover throttle is, what the modes are set as, so that you can match those in the new setup, how the receiver is configured, so mine's set up for CRSF, how the OSD is laid out, because I would try and keep the OSD to be similar in INAV from Betaflight. It'll just make the transition a little less jarring for you. And then when you've got all that information, I'd also then go to the CLI and then do a dump and then save that to a file, and also clear the output, do a diff all and save that to a file as well. That means that if you do this or you start it and you don't like it, then you can always go back to Betaflight. Once you've done that, then you can download INAV Configurator from this location. I'll put a link down below so you can get hold of it, and then you just go and flash it. Now, if you're not sure of the target, then what you can do is go and have a look on the manufacturer's site. Most manufacturers these days will tell you exactly what the target needs to be, and we can see here it's the SpeedyBee1 F45V4. So what I'll do is then I'll go into the INAV firmware flasher, select that, make sure I'm using the latest version and full chip arrays, download it and flash it just like I would with Betaflight. There isn't really that much difference at this point, and for those of you that know Betaflight, this INAV configurator will look very familiar. When it has completed, it'll reboot, and when you connect for the first time, it'll ask you what kind of model you're going to use, because INAV supports all these different types. This time I'm going to select a multi-rotor with 5-inch props, which is what we have here. Once that's done, it'll reboot, and when it restarts, we can see a couple of things. There are a couple of things here on the right hand side, and we'll have to have them all green in order to arm it, so we'll have to go through the setup. We'll do that in a moment, but you'll notice at the top the magnetometer is showing as blue, which means it's detected and configured the external magnetometer that we connected last time. So let's apply all of the settings that we took a note of when we had a quick look at the Betaflight configuration. Now INAV is here. The props are still on because we're not going to power it from the battery. Now, some older flight controllers won't power the GPS and compass unit, so it won't work without the battery. If that's the case, then remove the props and power it from the battery while you're doing this. However, in this case, we're quite lucky that this modern version of the SpeedyBee flight controller is actually powering the GPS and the compass. How do I know that? Well, here we can see that the magnetometer is not only detected, but it's also working. That's why it is nice and blue here at the top. However, at the moment, INAV doesn't know that we have a GPS and other things too. Now, as I move the model on the bench, we can see it's moving okay. That's good. Everything seems to be fine. What we're going to do is run down the side here. It's exactly the same way that INAV has worked since 1 point something. So what we're going to do is going to do calibration first. Two things we need to calibrate, and if you're familiar with Betaflight, this will seem a bit overkill, but you'll find that most systems that have more advanced GPS-based flight features will need this. One is a 6-position calibration, the other is the compass. Let's calibrate the accelerometer first. I'm going to have to move the model into each of the positions shown. So we'll click on calibrate accelerometer, tells us how to do it, and then we'll click it again. This is going to get the level. And then what I have to do is kind of put the quad into each of the positions. This is why I always, when I'm building things, I always try and do it before I have to kind of put the quad together. Now, it doesn't have to be exactly at 90 degrees. It'll still work if it's not, but you just have to keep it incredibly still for each of these positions. And we just have to work our way through, try and remember which ones we've done and which ones we haven't. Try and keep track of it. Last one is going to be upside down. So I'll try and hold it incredibly still, upside down. And the calibration has finished. So that's one of the really important steps done. We'll click OK. Next thing we need to do then is to calibrate the compass. However, I'm going to come back and do that at the end because there is some stuff we need to do here in the alignment tool. Because in this quad, as you can see, the compass isn't flat, and the alignment tool by default will expect the compass to be flat, and because it's at an angle, we'll need to sort that out. I've done a whole video about that, but we'll come back to it in a moment. Let's click save and reboot and continue doing the basics. Now it's rebooted, let's go into the mixer, have a quick look, make sure that it is set for a quadcopter. It absolutely is. So that looks good to me. It's basically the same as Betaflight at this point. Some more information in INAV about how the timers work and stuff, which is really important. I would leave all this stuff as standard because this matches how it's set up. So we'll leave it like that for now. Outputs at the moment are not turned on. That is the very last thing we do before we go and fly. That's a safety thing. DShot 300 is the ESC protocol that it's got set, and that will work with the ESCs that were in here, and it will mean that we don't have to calibrate. Ports is one of those things that we need to spend a little bit of time in. So USB VCP was for MSP data. UART1 was actually for MSP DisplayPort. UART2, if you remember, was set for serial, which is what it needs to be. UART3 was blank. UART4 was also set for MSP. UART5 was set for ESC telemetry, which is there at the end. And then the sensor, the GPS, is actually here on UART6. So we'll save and reboot that. Now, when it comes back up, the GPS isn't going to appear at the top because although it now knows it has a GPS, it won't start using it for navigation. So that's good. Just double check. And interestingly here, we can see that it's deleted some of the settings, and this can sometimes happen. This means that I've given it an invalid configuration. So what I'm going to do is I'm going to set the stuff that I absolutely need. That was for ESC telemetry. Make sure that MSP is off. I bet that was the issue. MSP display port. There we go. You can't have both of those set like we did in Betaflight. INAV is a little bit stickier about that. UART4 was MSP. Let's give that a go and see if it sticks. And it has. That looks an awful lot better. So if that's the issue, if you ever have a problem, I've made a video about that. I'll put a link down below. You can only have one thing per line in INAV, otherwise it gets very unhappy. Configuration tab is next. There's a couple of things on here that we need to do. At the moment, I would leave all this stuff. It's detected the 5883 magnetometer that's in this compass unit at the back. Voltage and current sensing will leave as normal. I'm not going to change anything in here. That all looks good to me for the moment. Failsafe, well, at the moment, we're going to return to home, but we're not getting the option yet. So we'll click save and reboot, because in the event of a failure, we want this quadcopter to fly back to us. That's one of the great things INAV can do. So let's jump onto the GPS tab. GPS tab should be higher up probably these days. This used to be in the configuration tab. It's moved to here. So we're going to turn on GPS for navigation and telemetry. That's going to then turn it on up here. Initially, it might go red if there's a problem, or it'll eventually just go blue as it gets data. U-box protocol. There are only a couple of protocols to take now. NMEA is no longer supported. So if you've got an older GPS, it won't work. Now, the next thing you need to do is your ground assistance type. You can leave it as auto detect, but for faster locks, then I would pick the location you are in the world. I'm going to pick European GLONASS because I'm in Europe, and that should make things a little bit faster. Unless you're traveling around the world a lot, I would just set it for where you are in the world. Once we've done that, then we can click save and reboot, and we're set. That should now give us the detail at the top that the compass is now working. So there we have it. The compass has, the GPS has appeared as well as the compass. So we know all the wiring and everything is working, but we kind of knew that because it was working in Betaflight. So that means the failsafe now is set for return to home, which is good. We're not going to do anything with easy tune. In this video, we'll fly it on the stock settings, PID tuning the same, advanced tuning the same. The thing we'll do in receiver tab is we do need to tell it that the receiver tab is going to be set for a CRSF receiver. Okay, and AETR was the order. Let's save and reboot that. And then back here in advanced tuning, the only other thing that we made a note of is what the hover throttle needs to be. That's not a million miles of what it should be. We know it's 1236 because we hovered the model and then took a note of where the throttle was, then plugged it into this and took a note of what that value is. So that's what it's going to be. At the moment, I would leave pretty much everything else as default for now, because that is just how it's going to work. But that means that when the multi-rotor navigation settings is enabled, it's going to just hover rather than dramatically drop or rise into the air. Click save and reboot. Last regular thing we do before we get into the compass is we will do the modes. Now, when you are new to INAV, there's a couple of things that I would probably set up. First of all, we're going to need an arming range. This is CRSF, so it's a binary for channel 5, which is what INAV calls auxiliary 1, and then we'll need some other ones. So I would say, let's do something like for the mode channel, which I know is channel 6 on my radio. Let's add it like that. Again, these little blue dots, just like Betaflight, show the channel positions. Horizon, we'll put like that. And then I would do something, or I'll tell you what we'll do. Let's actually get rid of angle. Let's put good whole old horizon on there. Then let's do something like nav position hold, where we can park it in 3D space in the middle position, and then that'll allow me to kind of show you how this thing flies when we've done it. And we'll do nav return to home. We shall do that for the mode switch in the 3rd position, and that will also be able to allow us to show that too. There's lots of other things here that we can set up. We don't need to set up, like in the old days, we'd set up multiple things at the same time. You don't do that. The only thing I might do, add the beeper. I think that's on channel 8. Just turn that on. I like that so I can find the thing. and we'll click on save. Last thing we'll do then is we will set up the OSD tab and then we'll come back for the compass. I do prefer the layout of this rather than the Betaflight one. It's much easier to kind of drag things around and see what you're doing. Betaflight one feels like you're zoomed in too much. We can see that INAV has already figured out we're using a HDFPV system. It's set it for HD zeros by default, but we're going to set it for avatar, which gives us this layout. This is great because this shows me where the safe elements are and where the unsafe elements are. So this is the edge of the screen. That's where the recording icons are shown. On this line below, this little purple line here, is where the standard avatar walk style information about battery voltages and delays and things are set. And I can drag stuff around in here just like I would normally, and I will spend a bit of time just moving everything into the position that you want. I would also add things like your altitude, distance to direction. Obviously going to have imperial for here, and we'll click save. I'll spend a bit of time trying to match what you had in Betaflight and have a look at all these cool things. With that all done, there's a number of things here that are saying that we cannot go. First one is the navigation isn't safe. That's probably because we don't have a GPS lock yet. There is a runtime calibration issue, and also the compass isn't calibrated. So this finally brings us to the piece where we need to calibrate the compass. Now the compass is at an angle, so we need to let INAV know that the compass isn't level, and that's relatively easy to do in the latest version because I did an entire video that explains it, but I'll put a link down below to it. But let's do this specific one. The first job we need to do is actually measure what the angle of the compass is at the back of the quad. It's usually going to be something like 20 or 30 degrees. This is a 30-degree mount, and I've just measured that using a good old-fashioned protractor, the kind of thing that you used to play with at school when you were measuring angles. And all I did was just kind of place the quad against the edge of a desk, lay a ruler against that, and then draw a line with a pencil and measured it with a protractor and figured it out. Now, because of that, there's a couple of things in the interface that we can see is a bit weird. It says the compass isn't calibrated, which is kind of fine. Because of that, the navigation is no longer safe, even we're now getting a GPS lock. And the runtime calibration, because those pieces aren't done, the runtime calibration can't complete either. The other thing is, if I just lift the nose on the quad, can you see that as I lift it, it starts to rotate? As I put it down, it's going to rotate back to the right. What we're looking here is for the heading here in the top corner. If I lift the nose, I'm not moving the quad, but there we go. She's swinging round to kind of 32, 31, 30 degrees. As I put the nose back down, it swings back round. That's a great indication that this alignment needs to be sorted out, and I would do that before the calibration. So let's go into the alignment tool, and what we have here is an image of the flight controller and also the GPS, and at the moment they're both set with the arrow pointing to the nose. Hopefully you can see that here. So they're both set in their default position. However, I know that I've had to mount my compass at a slightly weird angle. Let me just pull this down so you can see it, and then hopefully we can use these sliders here to get it in the right position. So I know that it's 180 degree out of phase, so it's actually pointing backwards, which means this needs to be 90. Hit enter. So that's now pointing in the right direction. I had to connect mine up because it actually connects here at the front. It was just the easiest way to do it on the particular quad. However, this isn't flat on mine, as we've already saw. It's actually a 30-degree mount. Measuring it here, it's actually 31. So I need to move one of these slides to see which is going to be the right one. It's not that, so let's put that back to what it was, 180. It's going to have to probably be this one. Yes, it is. There it is. That's moving it in the right direction. So I need it to be probably about minus about 31 degrees. So let's just type that in rather than fight with a mouse. Hit enter. And as I move the image around, does that look about right? Yep, flight controller is the right way round. We know that because if we lift the nose of the model, the nose of the virtual model lifts in the same way. And now that compass is orientated in the exact same way it is physically. Because we've done that, we now need to click save and reboot. INAV needs to restart, and it now knows that the accelerometer that's in the flight controller and the way the compass is aligned compared to the flight controller is now different. Now, as I lift the nose, has that made anything better? Not fantastically, although it's only moving a couple of degrees now rather than what it was before, but we need to calibrate the compass. So let's go back into calibration, and then here on the right hand side we have compass calibration, and we're going to have to click on this and then move this model in 360 degrees. When it's flat, I would then put it on the side, move it 360 degrees all the way around, nose down, and just do it in all orientations. So let me try and do that. It's going to be tricky with the camera where it is, but let's give it a shot. Also, do this well away from stray magnetic fields, so don't do this near large electronic devices and things like that. Ideally, out in the middle of the field where you're going to be flying it is the perfect place to do it. But let's have a crack here. I'm going to click Calculate Compass, and it's going to do it. So let's now put the quad, let's do 360 degrees, and we have to try and do this in the time that we've got. Hold it vertically and do the same thing. I have to keep coming back because the wire is going to get in a mess. So we'll do it upside down. Let's do it with nose down. And all we're trying to do is create enough reference points that that's going to work. So that's now finished. Let's click Save and Reboot again. And hopefully when it comes back, as we raise and lower the nose, what we're looking for is that that heading is right. For a couple of things, I'm pointing roughly west. So it should, the heading should be about 240 odd degrees, which is fantastic. Now, as I lift the nose, does the heading change? Go 241. With the nose down, it's still 241. That's fantastic. So with that all set up, it's time to go to field and to test stuff. The last couple of things that I would do here on the bench, just for safety. Last job in terms of the configuration for this quad, now that we've done that, is to enable the motor and servo outputs. Again, D-Shot 300 is going to work with these modern ESCs that are part of this model. So all I'm going to do is just say enable motor and servo outputs. When we plug the battery in, that means everything is going to burst into life. Let's click on save. I would potentially remove the props, power it, make sure that you can arm it on the table and the props all start together. And also when you turn the radio off, the props stop, just like we did with the Betaflight setup. Do that before you go to the field, and then finally reattach all of the props in their location, and we're ready to actually give it a test. So let's go to the field and let me show you what the position hold mode looks like, and also the return to home. And don't forget, you can install the INAV Lua script onto your Edge or OpenTX powered radio and have a display like this, which is a virtual cockpit, which gives you all the information and kind of shout outs when critical things happen too. I've actually moved over to my old trusty Tyrannus for this next flight, just because it's the one that I'm using for these kind of things. So that beeping that we've just heard means that the GPS has a lock. The better the GPS lock, the more accurate this thing is going to fly. So what we're going to do is we're going to arm it and go to a reasonable height, and then we're going to initiate position hold. Then we'll do a return to launch, and hopefully it's going to come back and land somewhere where the bag is. So let's arm the model, take off. And what we'll do is we'll initiate position hold. So now I've got my fingers off the sticks and the quad is managing its own height and position. I'm not touching anything. Now, is it super stable? Is it not moving at all? No, it's moving a little bit, but it's only a little bit. So I can just park that there. If I had a problem, a bee stung me on the back of my head, I could just park it, take care of that, and then carry on flying. But you can see here, this is pretty stable, and it also means that my hover throttle was pretty much spot on to begin with. And what I'm going to do is, now I'm happy that that is working really well, I'm going to fly further away, far enough, so that we can initiate, put it back into horizon, whoop,
Here we go. I'm going to fly away far enough so that I can do a return to home. Now it's probably as far as I dare, because I've got it. So initiate return to home. So it's going to turn back towards me. It's going to climb to the predetermined height. Again, I'm not touching anything. This is all return to home. This is INAV doing this. I'm going to back up a little bit away from the home location because I don't want it to land on me, because it's going to be within a couple of meters of that home location. Once it gets over my location, the home location that it's stored, it's going to turn around and it's going to start descending gently. I'm going to watch it in case it actually catches the bag, because it looks like it's pretty accurate today. And here it is coming down. Again, this is all INAV doing it itself, managing its position, managing the throttle. It'll hit the grass. And it's now disarmed. Not only has it disarmed, it's now making this noise so that I can find it in the grass. So that is how INAV stuff works. And that is the cool stuff that you get when you upgrade to INAV.
Thank you for watching the video. If you watch my videos and find them useful, then please take a moment to hit the like and subscribe button. It helps the channel a lot. If you really like what I'm doing here, you can become a Patreon and support the time I spend helping others and get access to lots of exclusive benefits. Link is in the video description. Remember that all the videos on the channel are organized into playlists, so you can easily use those playlists to find all the videos on a subject that you are interested in. Add Painless 360 to your searches on Google and YouTube, and it'll help you find my content for any particular topic. Thanks again for watching, and as always, happy flying.